So there are a couple of different notations that you might come across as you're working through domain and range problems. So we're going to try and show you the two major ones in this video. First of all, in all the previous examples, you had distinct points. What we call that when you have relations with distinct points is discrete. If a relation has an infinite number of points, this is called a continuous relation. Most of the functions we deal with are continuous. Not all. A lot of the word problems will end up being discrete. But when we're looking at a linear function or a quadratic, a lot of times you're going to see a line that's connected. That is a continuous function. That means you can plug in any fraction, decimal, anything you want to that function. Discrete functions have restrictions. They either need just whole numbers or just integers or something like that. That would be a discrete function. So it's kind of the difference between a light bright where you're plugging in just lights versus an Etch-a-Sketch which has a continuous line that you have to use to create a picture. So let's get to the notations. How do we write these? Set notation is what you're going to see most often, so it's what you should focus on the most. It uses inequality symbols like a less than or greater than or less than equal to, greater than equal to. When a boundary is included, so when your starting value is also a part of the function, then we use the greater than or equal to or the less than. One of those should be less than or equal to. Sorry about that. We use those two symbols, less than or equal to, or the greater than or equal to symbol. Why? Because it contains that value. It's equal to that value. If it's not included, that's when we use just the less than or the greater than symbol, because the domain or range is not a part of that value. It just starts there, just like when we do open circles and closed circles and all of that back in previous units. When either infinity or negative infinity is in the bounds, we're going to use those less than or greater than symbols. Why? Because you can never actually reach infinity. Okay, so I'm going to show you examples and show you kind of what I mean by this, but let's get the notes down first. The other option is to use interval notation. It looks cleaner, but it can also be a bit confusing because it uses brackets and parentheses. That gets confusing because we use parentheses for other things like ordered pairs. But brackets in this case would be when the boundary is included. Brackets are analogous to the greater than, equal to symbols over here. We use parentheses when it's not included, like a less than or greater than situation. We also use parentheses when it's infinity or negative infinity. Again, because you can never reach infinity, so that would not be included. So that's why you get the less than or greater than over here. That's why you use the parentheses over here. So let's do an example. This is a continuous function. We're not going to do examples of discrete functions because that's what we did in the previous video. But this is a continuous function because it's all connected. We didn't just put ordered pairs. We put a whole weird little curve here. So the domain is all your possible x values. What you're going to do to find the domain is you need to find the very beginning of this function. This function starts right here. The x value for that is -3. Okay, you can just draw yourself a line to the x-axis to see what that is. So it starts at -3. -3 is less than or equal to all your other x values. This thing continues on until we get to this 6, the very last point of the function. Notice though that we have this open circle here. That, just like back in Unit 1 and 2, that tells us that the 6 is not actually included in this function. It's merely a boundary. It's the end. So it stops right before you get to the 6. So this is where we would put just a less than 6. So x is between -3 and 6. You're always going to have a less than and a less than, and then you just have to decide whether to put an equal to or not, depending on whether you have a closed circle or an open circle. In interval notation, it would just be -3 to 6. You would put a comma. It kind of looks like an ordered pair, except if you have an equal to, so this is a solid circle, then I would use a bracket. If you have an open circle where it does not include that boundary, then you would put a parentheses. So it looks like a weird, sloppily written ordered pair. Okay, but they mean the same thing. So you have to be prepared to see either one of those when you're looking at different worksheets or notes or things. All right, now for range, we're going to do the same basic thing, but this time I am looking at my y values. So instead of an x in the middle, I'm going to have a y. And what I always do is I go ahead and put my y, and then I put my less thans and less thans because I know I'm going to have those, and then I think later about whether to add the equal to or not. That's just me. You may not like to do that. But so I'm going to come over to my function, and I'm going to start at the very bottom. I'm going from bottom to top here. The lowest y value is -3. Okay, so that means I'm going to put a -3. This is a closed circle at -3. It truly does include -3, so I'm going to put equal to. Then I'm going to go to the very top of this function, which is here, and I'm going to see what the y value is there. That y value is also 6. They're not always going to be the same. That's just a coincidence. So the top y value is 6, and it is an open circle, so that means I'm going to have an open circle there for the end of my range. That means your interval notation also going to be the same thing. So you don't have to remember to put x's and y's on interval notation. It starts at -3, and that's an included boundary. It ends at 6, not included. All right, so that's what that would look like. Now, what about if we have arrows? Most of the time, we don't have weird little open circles and weird curves that just start randomly and end randomly. We have lines, we have parabolas, we have exponential curves. So how do we write the domain and range of that? Well, the domain here, if you think about, remember I told you to start at the beginning. I told you to go all the way back to the beginning and find your first possible x value. Well, it's impossible to go to the beginning of this because I have this arrow here that says this is going forever to the left. So the beginning of this is -infinity. I'm going to have my x's with my less thans. The beginning is -infinity because it keeps going forever to -infinity. The end of it is the same basic thing. My very last x value, well, it keeps going forever until I get to +infinity. This thing says it's going to keep going to the right forever and ever. Since I have that arrow, I'm saying x goes from -infinity to +infinity. There's lots of different ways to write this. I put that here. How many ways can we say the exact same thing? This is the thing about math. We know we give you lots of options. So one option is using this interval notation, or sorry, set notation. Notice I didn't put equal to. That's because this arrow is never ever going to actually get to -infinity. It's just going to try. It's just going to keep getting smaller and smaller. So it's not equal to -infinity. It just tries. Also, a lot of times you'll just hear us say the domain is all real numbers. Because you can plug in anything you want. Any fraction, any decimal, any negative, any positive, doesn't matter. All real numbers. Using interval notation, you would write it like this. Remember I said we use parentheses if it does not include the boundary, and it does not include -infinity or +infinity. So that's your interval notation. The other way is with this little symbol. This is my favorite because I'm lazy and it's easy. You would just write 2 lines as the back of an R. It's an R with 2 backs. That's all it is. And that just stands for all real numbers. So it's a quick way to write all real numbers. You might like that. The range, remember range is all your possible y values. So how low does this function go? How high does this function go? Well, if I try to find the bottom of this, there is no bottom. It's going to keep going to the left and down forever. If I continue this line out, it keeps getting lower and lower. So it goes to -infinity. So I'm going to say -infinity. Remember, this time we use y's with less thans. It never actually hits -infinity, so I do not put an equal to. And then the same thing's true if I go up. It goes to +infinity and does not ever hit it. In interval notation, -infinity to +infinity. You could also write all real numbers. All right, that is it. Sorry for another long video. I swear I'm trying to go through it quickly. Go ahead and try your U-tries, and check your key in the classroom or on the website, and I'll see you on the other side. Bye.